Using a table of z-scores. For calculations involving z-scores other than whole numbers, a table of z-scores may be used. Tables of z-scores may be used to determine population proportions or probabilities. So for example, the results of a recent mathematics test are known to be normally distributed with a mean of 65 and a standard deviation of 8. A student is chosen at random. Find the probability that the student achieved below 60. So let's have a look at the solution now. So a raw mark of 60 corresponds to a z-score of negative 0.625. So that's using the z-score formula. Z equals x minus mu over sigma. Now, the probability corresponds to the percentage of students that lie below a z-score of negative 0.625 on the normal distribution. And here's a diagram that represents that. So it's actually the shaded region here. And we want to find out what percentage sort of lies in that shaded region. Now, the issue that we have at the moment is that the z-score that we're talking about is not a whole number. So we need the table of z-scores to determine what that percentage will be. The percentage of students who achieve below a z-score of negative 0.625 may be found using a table of z-scores. Now, the following 2 pages contain a table of z-scores accurate to 2 decimal places. So if you go to the next page, so that's one, there's 2 tables, so that's one of them there. Okay, so we'll have a look at that shortly, so how it works, and we'll have a look at how we determine the percentages. So for example, to find the percentage probability of z-scores less than or equal to negative 0.625, firstly we round the z-score to 2 decimal places. So negative 0.625 rounds to negative 0.63. Next thing we need to do is to locate the cell in the z-score table that corresponds to z equals negative 0.63. So this is row negative 0.6 and column 0.03, and the value in that cell is 26.43%. So I'll demonstrate that using this table. So if you now go to the table of z-scores, so we want negative 0.63, so that's this row here, this row there. Okay, so I'll just make that a bit clearer there. So it's that row there, and it was column 0.03. So this is the column here, okay, 0.03, and where they intersect, okay, it's 26.43. Okay. So going back to our example. Therefore, the probability that a student chosen achieved a mark less than or equal to 60 is 26.43%. Okay, so back to our table of z-scores. Okay, so you can see here that there's 2 tables in your notes. The first table shows z-scores that are negative. So you can see there that the z's below 0. And if you go to the following page, this table is for positive z-scores. So z-scores above 0. And the percentage is the percentage from basically negative infinity, or basically everything under the curve up to and including that z value, but obviously not above that z value. So for example, if you wanted z equals 0.44, okay, you would go to z equals 0.4, and then you would go to column 0.04 to make up the number 0.44. So it's a bit like a stem and leaf plot in a way. You've got the stem and you've got the leaf. Okay, we'll have a quick look at the questions. So, and the solutions will be provided at a later time, or the worked solution at least. So, okay, so if you have a look at the question, here's the situation. 10,000 students attempted a maths test. The results were normally distributed with a mean mark of 82 and a standard deviation of 6. So part A, how many students achieved a mark between 85 and 90? Okay, part B, how many students achieved a mark greater than 95? So just be careful with this one. The table of z-scores shows values that are less than, not greater than, the z value of interest. But also note that what percentage of students or what percentage of scores lie completely or lie totally underneath the curve or entirely from one end of the curve to the other. And that's of course 100%. So you might want to use that as a bit of a clue to help you with that question. Part C, how many students achieved a mark less than 65? And that one's, I think, fairly straightforward. I think the example that we just looked at will help you with that. Okay, D. Okay. A student is chosen at random. Find the probability that the student achieved a mark between 80 and 85. And part E, and this one probably will take you a little bit more time, determine the raw marks that correspond to the 80th and 90th percentiles correct to the nearest whole number.